Hello everyone, hopefully you are able to hear me. Okay, so this is section 3 and we are going to be together during the labs, and we don't actually have a lab in each week, and the tentative schedule is on the TA's website if you need to look around. But at the beginning of each week, if there is a lab, I will also send an email and also send the documentation, etc. if we have a handout or some example files, etc. So starting from lab 3, we are going to be on the hybrid schedule, but labs are online only. So we are going to just meet on Tuesdays at these clocks. And on the announcements, if you click on here from the teacher's website, we have this TA's website, and these announcements are basically what I sent you through email. And you also have some materials down below. And with this lab, we are going to use Draw.io, a software to create diagrams in general, and we are going to use it for drawing ER diagrams. And also we expect you to draw an ER diagram of your project using Draw.io. So right now, I guess you uploaded the project group documents on Moodle, and we are going to also like assign the remaining people, and then we are going to announce which project you get for your group. And we posted the descriptions of the projects. You might have already looked at each project. Basically, you are given a description for a database, and for the first stage of the project, we are going to draw an ER diagram that represents the database for that specific topic. And to draw the ER diagram, we want you to use Draw.io. So the topic of this first lab is drawing ER diagrams with Draw.io. If you look at the other materials section in the website, there is the link to Draw.io. It is available as an online tool. There is also download versions if you need. We are going to use the online version for now. If you click on that link, you will be directed to the website, and you have the option to save your files on the desktop or on cloud devices if you prefer. So this is basically that option. And like if you when you open it first, it will ask you to choose a device to save your files. Since I'm not opening it for the first time, it already knows that I would like to save my files to the device. But we are going to create new diagram. So there are some templates for different diagrams, but we are going to use the blank diagram templates. There is also in some place it's here actually. There is the template for ER diagram, but it's using a different style. So in the class, the teacher is going to or already introduce you to a ER diagram style. That's the one that we are going to use, but this follows a different style. So we are going to go with blank diagrams in here. So I'm clicking on blank diagram and clicking on create. So it brings me a dialog to save my file. Let's call it like lab 1 section 3, for example, and I'm going to save it as a draw.io file with the extension .draw.io. And then this is my workplace. So let me also, you cannot hear me. Is it an issue for other ones as well? Okay, maybe it's okay. Okay, thanks. Bura, maybe it's about your system. Okay, the majority is able to hear me. So if you also look at the sorry handout that we sent to you. So in this handout, we basically have like three parts. In the first part, we gave you an ER diagram and a corresponding description. So this description is actually similar to your project topics. So this could be a project topic as well. And we expect you to draw such an ER diagram that corresponds to this descriptions. In the second part, in this handout, we have some little summaries of each ER diagram elements. So these, you should know them from the lecture, but we are like reminding some of the concepts here. And in this third section, we have something like a tutorial. So the labs are going to be in a tutorial-like fashion. So you don't need to upload anything at the end of labs. So there is no grading for the labs, but all the topics we cover during the labs will have a corresponding task in the project. So if you are following the labs, then you should have no problem with the project, because the project is not that hard in this course. It's kind of like an introduction to the database concepts, and we basically want you to like have experience with different aspects of it, rather than to create a big project. So these are like including some tutorial stages from this lab, actually, how to create each element, etc. By the way, there is also attendance, but the attendance is going to be like contributing to your course attendance. So it is it has the same weight. So if you miss some labs, that's not a problem. I'm also going to post the recordings of the labs so that you can like watch them again, or if you miss them, you can like look at the labs. So for the newcomers, we just went into draw.io, the tool that we are going to use for drawing ER diagrams. We created a new general diagram, and in here, like having a mouse with a wheel might help or make things easier, because if you click on the mouse wheel, you can get around. Otherwise, you can click or you can hold the space key on your keyboard to shift your view. There is also the zoom in, zoom out options. And basically, in Draw.io, we can create shapes. And in each shape, we can have some text. And on this left toolbar, we have this general shapes. There are different categories of shapes, and you can like resize this toolbar on left if you need to, or you can like open and close some of the toolbars if you don't have them. But this is the default view, and this default view is okay for us. So if I want to bring an item, create a new shape, I just need to click on that shape. So a rectangle. So we are mostly going to use a limited set of shapes for the ER diagram. We have rectangles, triangles, and diamond shapes. And we have also lines. So we are going to only use a subset of these items. When you have your item on the workspace, you can click on it. You can like click with the mouse left button and drag that element around. You can resize the elements. And while the item is selected, if you type something on your keyboard, it will be written on top of that shape. The right toolbar is based on your selection. So if you choose the shape, you have a bunch of style options, like the line width of your shape. You have different tabs as well. So if you choose the text one, you have options for text. Maybe sometimes we need to underline that shape, the text, then we can choose the underline option from there. And these will be like enough. There is also a rotate shape option on the arrange tab. We are going to use it for the triangle only when we are creating user relationships. You can resize your element around. So I'm going to go through the different elements of an ER diagram and try to create them in Draw.io. So we have, first of all, we are creating a database to store data, right? And the important thing about that data is that it has some relations. We are also keeping the relations. Otherwise, we can store all of our elements in a text list, for example. But why we are using the database is that we would like to retrieve the data in different shapes, let's say. So for example, I can have a list of users, and maybe I would like to get only the users with the name starting with the letter L, for example. Then I need to, if it was a simple list of items, then I need to search through every item. But in databases, there are uh, faster algorithms in the implementation that you don't need to worry about, but they will work in a fast manner to retrieve your data in different shapes. In the database, we also keep the relationships. So some of the users are maybe going into classes, then I can retrieve such data as well. With entity sets, we keep the objects, the separate objects. For example, the users could be the entity set in here. Courses that we have could be another entity set. And we use the rectangle shapes to show an entity set. So in here, in Draw.io, I have my rectangle. And while the rectangle is selected, I can type user into it so that this is my user entity set. I will zoom in a little bit and drag the mouse around. By the way, if you have any questions, you can interrupt me and ask at any time. So this is my entity set. This corresponds to an object that I would like to store in my database. And for each object, I also store some attributes. For a user, so let's say I'm storing a user, what I should store that is going to correspond to a user, or what attributes that I need to remember to say that this is okay, a user. So those items, we describe them as attributes, and we use the ellipse shape to describe an attribute. So attributes, you can think of them as like if you have an Excel sheet, Excel paper, each column could correspond to an attribute. In that case, in every row, you might store different instances of a user, for example. With attributes, we are using the ellipse shapes, and to connect an attribute to an entity set, we use simple lines. So we should have some ellipse shapes, first of all. Let's go into the Draw.io. I will create a new ellipse shape. For example, for this one, let's write name attribute. So I'm going to reshape it to a better size, because if you have like huge shapes with little text in them, it might be disrupting. So I have my attribute and the entity set. I need a simple line connecting them. There is the line. If you click on the line, it will bring the line. What's different about lines is that they have two ending points, and you can attach those ending points to existing shapes. So I can choose this line, I can carry this line around. If you click and hold on the middle part by mistake, it will create an arc. So every time you click and hold on the middle part, it creates an arc. So be careful about that. I will undo these operations. So if you want to just carry it, just choose when the mouse cursor is looking like a cross. So you have blue ending points on each end of a line. You can click and hold and drag your mouse around to carry the endpoints of the lines. And we would like to attach these lines on the shapes that we got. So if you bring the line, I will zoom in further. If you bring the line on top of the item, you will see a blue outline. That means that you are attaching this endpoint to the center of this item. There are also different anchor points on different corners of each shape. You will see very little blue crosses there. So most of the time we would like to anchor the lines into the centers of the elements. So I will drag one endpoint into the attribute and drag one endpoint onto the user entity. So if you are able to connect them into the centers, when you carry your items around, then the shapes would look better. So if I choose the line, I can deattach it, so it's not connected to the name. And then let's try to anchor it to one of the corners, for example, this top right anchor. Then if you like carry it around, it makes contact to the top right corner anchor. So that's why usually it's a better idea, because we are going to be moving our elements around. It's a better idea to just connect it to the centers. And when you have the element that you would like to create a copy of on your workspace, it is easier to just duplicate the existing ones. So rather than to create a new attribute, for example, now let's say I would like to create an attribute for surname. What I can do is you may right click on the ellipse shape that we have and click on duplicate. So that duplicates that item. You can also do it for the line. Right click and duplicate. And we can then attach these items together. And only thing I need to do is to change this into surname. You can either double click on this text to edit it, so you can write surname on top of it. You can again resize it. Also, sometimes knowing the shortcuts, hotkeys could be beneficial. So if you click on this ellipse shape now, Control D is the hotkey for duplicate. So if you duplicate this attribute, now we can write ID for this one. So if we try to get this example, I need ID and I also need a password for each user. So I'm going to duplicate this one as well and write password for it. So there should not be any attributes that are not connected to an entity set. So I need lines to say that, okay, this is an attribute of this entity. So I will duplicate these lines as well and connect them accordingly. Sometimes people mistakenly connect two attributes together. So this is a no, this is wrong. If there is an attribute, that attribute can be connected to an entity or a relation. We are going to see it in a minute. So far we are done with entity sets and attributes. We can store some data in our database. We can store a bunch of users. We can store a bunch of courses, for example. And if we would like to relate some entries in two different sets, we are using relations. So for example, in here it says that teachers. So teachers are teaching courses, let's say. In this case, we store the teachers on a separate entity. We store the courses on a separate entity, and we would like to relate different instances from each entity. We are using relations in that case, and you can think the relation as a table as well. So think of it as a table. In that table, I am storing which teacher is teaching which course, and I'm storing their primary keys. We are going to see them in more detail, but for a relation, we just need a diamond shape. So we have this diamond shape here. I will bring it here, resize it using one of these blue dots around, and maybe this is, again, it could be teachers. And let's say I will duplicate this entity as well, or let me show you choosing multiple items. If you like drag your mouse around with the mouse left button, you can choose multiple items, or you might also hold the control key on your keyboard to choose multiple items. Let's say I would like to create a course with course ID and course name, and then I can reuse these items. I will just click on Ctrl D to duplicate them and just change the text. So I choose this item. Let's write course on it For this one, let's write course ID, and for this one, let's write course name. And to show the primary key, we underline the attribute, right? So for user, the ID is going to be our primary key. Therefore, if you want, you can choose that shape and use the hotkey Ctrl U on your keyboard. Or you might also choose that shape and go to the text tab, and then there is this underlining option. The hotkey is also visible there if you wait on that button. So now we would like to relate these two different entities with the teachers relation. I'm going to duplicate the lines to connect them together. And with a basic relation, what we have is, again, simple lines. But we might have more. With the relations, we can talk about participation and also cardinality. So two different concepts. Participation says that if you have total participation on one side, then that means that every entry in that entity should participate into the relation. So if we go into our example in here, so users are teaching some courses in our case. And if you don't have any total participation, that means that some users might teach courses and some may not. So there could be some users, not losers. There could be some users that are not teaching anything, and there could be some courses that are not taught by anyone. But if I make this line connecting user to the teachers tick, how do I do it? So I should choose that line, and under style, there is this line width. It's currently 1 point, so I can make it 2 or 3 points. So if I have a width line, a tick line, that means that every user should contribute to this relationship. Then I'm saying that every user, if I have a user, that user should teach something. And furthermore, if I have a tick line on the course side, then I'm saying that every course should be taught by someone. So these are things that we decide based on the description. So I might have bold lines on either side, or none of them, or both of them. These are all possibilities. The second thing is there is cardinality. So with a relationship, we can also talk about cardinality, meaning that how many instances of each entity that we are relating, or how many of them are possible. So there are three different options that we might have: many to many, one to one, and one to many. And with one to many, you can like reverse the sides. And we are showing this using arrows on our lines. And remember, I mentioned that there are different styles of ER diagrams. The one that we are following, if there is an arrow, it is always next to the relation. So with the other style, the arrow could be towards the entity. It could be next to the entity. But in our style, the arrows are always next to the relation if there are any arrows. So be careful about that. Sometimes people do the mistakes, and if you make the mistake, then like the reverse arrows, how to interpret them is kind of hard. So we expect you to use the same style to be on the same page. So going back to our example, let's for now make the lines just simple lines. By the way, I should also say that if you make a line thicker and create a new item, okay, it did not happen this time, but if a new shape has a thick line, then the other new shapes that you create will also have the same line quality. So just be careful about it. Then you need to like decrease the thickness, and then like any of the new items will follow that line width. So to remove any of the items, you can right click on it and choose delete, and also you can use the delete key on your keyboard while that element is selected. So for now I just make these the simple lines, and if you click on one of the lines, you have, for line start and ending points, you have the option to put an arrow. So you can, like, if it looks like an arrow, it's okay for us, but let's use the classic one. And one thing is that we don't know which part is the starting and which part is the ending. Actually, if you would like, you can go to the actually, okay, we cannot see that as well. Okay, with lines we don't know which is the starting and which is the ending point, so we will try it with one of them. I will choose for the starting part, and this is actually wrong, right? This is not something we would like to have. If we have an arrow, it should be always next to the relationship. So I would like to reverse it. If you right click on the line, there is the option to reverse a line. If you reverse it, then this is the correct position. So with this line, I made an arrow on this part. Let's, with this line as well, put an arrow, and this time I did not need to reverse it. So how we show a one-to-one relationship? If we have arrows on both sides, then that means that one user can teach only one course, and one course can be taught by only one user. So for a relationship like teachers, maybe this is not that ideal. So if you think about it, some teachers can teach multiple courses, and the same course could be taught by different teachers. Most of the time, one-to-one relationships are rare. But if you want to or need to make it, this is how we do it, with arrow shapes on both sides. And if you would like to revert it back to a simple relationship with many-to-many, with simple lines, then this is a many-to-many relationship. So each user can teach multiple courses, and for each course could be taught by multiple users in that case. It's not a necessity though, so there could be still some users teaching no courses, and there could be some users that are teaching only one course. This is setting the higher limits. If we also look at, there is also one-to-many relationships, and with this about the site, people could have sometimes problems. So you can use this image as a reminder. So consider that an owner has some dogs. So for each dog there could be one owner, let's say, and for the owner there could be many dogs related to. In this case we have leashes of the dogs, and if you think this vertex as the relation, these leashes are kind of similar to an arrow. So the arrows are towards the relationship, which is in the middle. For the owner's side, we do not have any arrow, but for the dog side, we have the arrow. So this means that an owner can have many dogs, but a dog can have only one owner. So there is no total participation, which says that there could be some dogs without owners currently. If we make this line on the right side tick, then that would mean that, okay, for every dog, there should be an owner. And if we had a tick line on the left side, then that would mean that every owner should own a dog, at least one dog, but there could be many. So this is how we show the cardinality as well. And for participation and cardinality, of course, we can mix and match them. There could be participation constraints and also the cardinality constraints. And there are some examples about those in the handout if you want to remind some of the concepts to yourself. And sometimes we would like to have relationships using different instances of the same entity. So in that case, we might need to connect the same entity twice to a relationship. And let's do such an example. In that case, let's say for users, I'm going to duplicate this relation. By the way, if you zoom out in Draw.io, everything is a page, but if you move your items around, it automatically creates new pages. So fitting the diagram on page is not that big of a deal. And since you are going to upload the Draw.io files directly, you don't need to think about the page setup. You don't need to print anything. So let's say users, and let's follow this example. Let's say in this example it says that teachers are inspecting other teachers. In this case, one part is the inspector and one side is being inspected. And if you have a self relation, it makes sense to write something on the lines to give different roles. So in this case, it could be also like, let's say users are friends of other users. And in this case, let's say friend request is coming from one side to the other side. So let's say this is the friend of relationship, and I will create new lines. And this time, let's say on one end, I connect it to the center of the user, but on the other hand, if I connect it to the center of the diamond shape as well, I cannot have two lines in a good way. So it is better to connect it to the anchor points this time for such self-relations. And I'm going to duplicate another one, connect it to the one of the anchors of this diamond shape, and also with this one you might use the center point of the entity, or you can again use some of these anchor points. Also be careful, you might also, like, if you leave your items around, you might shift them and they might look like as if they are connected, but when you carry them around, so most of the time to have a better view, we might need to carry the items around. So it is better to always attach them to some anchors or to the centers of the elements. So in this case, I have two different lines. And for these lines, when the line is selected, I might type something, for example, from. And for this one, let's write to. Again, with total participation and also with the arrow shapes, the same things apply. So I can also reverse them to correct them. So again, if there is an arrow shape, that is always next to the relationship. So I will revert it to none. So we also sometimes have ternary relations. So these are not that different than our simple relations. In the simple relations, we are relating two different entities, but with ternary relations, we have three different entities. And in this case, how we do it in the ER diagram is just by including, let's say, for example, users are teaching courses in classrooms. And let's say for each classroom, we are keeping a class ID, for example. Let's duplicate these lines. And maybe for each classroom, we might also have, in this example, we did not show the attributes. So if you have an entity, there should be at least one attribute always. Otherwise, what you are storing for that entity is not, it is not there. Without an attribute, what do we store is not that meaningful. So for example, let's also have for classrooms the floor number, and let's say this is maybe not a primary key. So let's say a class ID is enough to find a unique classroom. And then I attach my classroom as the third entity. So this is a ternary relationship. Teachers is now a ternary relationship. With ternary relationships, what we might be careful about is how we place the arrows. So for example, to read such a relationship, it is hard to consider all the three entities at once. So what I would suggest is Like, for example, between the user, course, and classroom, let's follow this example. Let's say that on the course side, we have the arrow. On the classroom side, let's have the arrow. Then how to read it? I suggest that if you hide one side, so for example, if I, for now, delete the course part, then this is similar to a basic relation, right? So classrooms are like the docs. So for each user, there could be many classrooms, but for one classroom, there could be only one user. So if I hide the classroom side, then I will be saying that, okay, this is a many-to-many relationship between the user and course. For a user, there could be many courses. For a course, there could be many users. So trying to read it when three entities are there is kind of harder. So I suggest them looking by hiding one side at a time. And we also have aggregate relationships. With aggregate relations, it is kind of similar to ternary relations, but it is also different in the sense that we are kind of connecting relations together. So in such example, let's have this without an arrow. In such example, we are saying that, okay, we are teaching courses at classrooms. And remember, I said that for a relationship, we can think it as a table that connects users, courses, and classrooms together. Then in this list, I am keeping which user is teaching which course at which classroom. And consider such an example that there are online classes and we are not using classrooms, actual classrooms, let's say. In that case, sometimes we might not have a classroom for that relationship. And if there are many online courses, then for many of the things that we store in the table of teachers, there will be empty data for the classroom. In such cases, aggregate relations make sense. So most of the time, let's say users are teaching courses without a classroom. So let's say we only need a classroom in some instances. In those instances, it is more meaningful to connect this classroom on top of an existing relationship. Let's say we have this existing relationship between user and course with the teacher's relationship. We can say that we attach the classrooms with a separate relationship. So I will have a copy of this teachers. Let's rename it as like at. So teaching is going to be at a classroom. And on one hand, I would like to connect classroom to the relationship at. And the other end, actually what I would like to do is to connect these relationships together. But for the notation, we never do that. We cannot connect two relationships with a simple arrow, with a simple line. To show that we are defining this new relationship on an existing one on top of teachers, we include a dashed rectangle around the relationship and the entities that are connected to that relationship. So in this case, I create a new rectangle. For the rectangle, I can resize it, but you will see that it is overlapping my existing shapes. So Draw.io is layer-based, and each new item comes on top of the existing ones. I can right-click on this rectangle and choose to back, to send it to back. Now I have it on back side. So the rectangles should include the relationship and the entities that are connected to that relationship. So in that case, I have user and course in this one as well. And inside that rectangle, there should not be multiple relationships. Why? Because actually what I'm doing is connecting two relationships together, but I do not show it with a simple line. I show it with a dashed rectangle. So if you choose this rectangular shape under the Style tab, you also have line options. You can choose a dashed one to have this dashed rectangle for the aggregate relationship. And now I will connect this other end to the outer rectangle, the dashed rectangular shape. So now I'm saying that, okay, users are teaching courses, and sometimes I include this teaching act. I carry this teaching act into a classroom. On those cases, I will use this relationship at and relate this teaching operation to a classroom. With such setup, we can have we can store the courses that are taught by users, and if you need the classroom, you use a separate relation and store which user is teaching the course at which classroom. One additional thing is we have is-a relations. With is-a relationships, what we are defining is a hierarchy between different entities. So with an is-a relation, it is always about the entities, and we have one side that is on top of this is a triangle, the parent, and then we can have multiple children. So on draw a side, I need this triangle item, so I will click on the triangle, carry it around. Since the last item was dashed, I need to revert it back to solid lines, but you will see that it is pointing towards right. So while the item is selected, there is this rotate symbol. If you click on there multiple times, it will have the correct rotation, and then we write is-a on top of it, and you can use the second line. If you choose this line and click on the enter a bunch of times, it will like put it on a different line. Let's use the second line. So this is my is-a relationship, and with is-a relations, I always expect one entity at top, such as user. I connect the entities to the is-a relation with simple lines, but this time which side I'm connecting to is kind of important. So therefore, maybe you might want to use the anchors on top and on the bottom side. So I'm saying that, okay, user is the parent, and children could be teacher, student, and for example, staff members. And for each of them, I would like to use the simple lines. And these should be connected to the bottom side. But one important thing about the is-a relationship is that there should be some sort of difference between the children in terms of attributes or relationship capabilities. So for example, in here, let me get the ID and maybe the name from user. I'm clicking them while holding Control key on my keyboard, Control D to duplicate. I will carry them here and connect them. So if I have such setup, this means that all the children of user inherit the attributes of the user. They also inherit the relation capabilities. So if I say, okay, users are attending courses, let's say, then this means that, okay, teachers could attend courses, students can attend courses, and staff can attend courses as well. So all the children inherit what the parent has, but we expect some sort of difference in between these children. Otherwise, we can just store an additional attribute. So instead of this is a relationship, I might store a type for the user. and I can write whether this is a student or a teacher or a staff member in this attribute as well. But with a is a relationship, we actually store different things sometimes. For example, maybe for teachers, we would like to store an additional attribute like salary. Maybe for students, let's say, students are attending classes and teachers are not going to attend classes. We can define different relations for the children. So this is what I'm referring to as having some difference in between the children in terms of the attributes or the relations that these are making. In this setup, the users cannot attend to courses. Only students, a special type of user, can attend the course. And for teachers, we store an additional attribute, which is salary. And maybe for staff members, we might have some additional relations, etc. So in your project, if you are using, for most of the topics, we have some is-a relations. If you are using the is-a relation, there should be some sort of difference in between the different children. So be careful about those. And there is also weak entities, one last item that we have. With weak entities, let's actually maybe start it on the next hour. So right now, let's give a 10 minutes or 13 minutes break, for example. Not for example, yanlış dedik. So let's give a break now and let's start with weak entities because sometimes people do mistakes with weak entities. So it is something maybe needs some more time. Let me that. Okay, let's meet at 1:30 and have a break. Yeah, sure. Yeah, yeah. So one problem is that if you click and hold the rotation symbol, it will also rotate the text. Uh, and another problem is like you might encounter if you was it this one? So if you hold the rotation symbol, it also rotates the text. What should you do is just click on this rotation symbol a bunch of times, 3 times, and then it also rotates the text. Okay. Any questions, problems? Okay. Let's give a break. Okay, let's continue. Before we start, are there any questions, problems? Okay, sure. Okay, sure. So there is no problem with the ternary relation, right? You just relate three different entities. Okay. So with aggregate relations, so in the ternary relation, if you have a ternary relation, you are saying that basically every time I have a teacher's relationship, there should be a teacher, a class, and a course. According to how you set up the database, you might have some required fields and some fields that are not required. And with relationships, we try to have everything required most of the time. And that means that if a teacher is going to teach a course, there should be always a classroom for that. But if we are not assigning a classroom for every teaching activity, for example, for the Ternary relation, let's say I keep a table. In that table, I have the teacher's ID, the course ID and the class ID. And let's say I sometimes omit the class ID because the course is online, for example. If there are lots of courses online, then I'm not using this class attribute most of the time. Not the attribute, but on the table for the class column. If I have lots of empty lines, it is not efficient in terms of the storage. With the aggregate relation, we assign the teaching activity to the courses, because if we are teaching something, there should be always a teacher and a course, let's say. But if most courses are online, then using the teacher's relation only is sufficient. And if I need a classroom for a teaching activity, then I can include the classroom with a separate relation. In this case, this in relation is the aggregate one. It is defined on top of an existing teacher's relation. Does that kind of answer your question? Yeah, sure. Mhm. Additionally, it also makes sure that if I'm attaching a classroom to something, that something should be a teacher teaching the course. So a different implementation could be like relating the class to the course, for example. But if I want to make sure that course is being taught by someone, then the aggregate relation is the better way to go. So what I try to say is that, so instead of this aggregate, I might also assign classrooms to the courses, right? This is a simple relation. But in this picture, then for some of the courses that are not taught by anyone, I might still have classrooms. With the aggregate relation, I make sure that I assign classrooms to only to the courses that are taught by some user. Uh, did you see the aggregate relation in the class yet? Okay. Okay, maybe this makes it more clear, and with more examples, it might make it better. No problem. Any other questions, problems? By the way, I'm also recording these with a separate software, therefore you do not see the record symbol in Zoom, but I will also uh, upload them in case there is some something discussed that is not available in the first backup videos, etc. But usually we try to cover the same things. So one last item we have is the weak entities. And with weak entities, sometimes people have some incorrect approaches. So with a weak entity, what we try to mean is that that entity, or let's say it's like this. For that entity, we are storing different entries, right? We are storing different objects. If we cannot uniquely identify one instance of that object by itself, this is a weak entity. We need some relation to find a unique entry for this entity. So it is better to go with an example. In this case, the example is customers are borrowing loans from the bank, for example. We have the borrows relationship. It is a one-to-many relationship, meaning that a customer can borrow multiple loans, but for a specific loan, it is only given to a customer. So for a loan, we store the date and amount, let's say. Maybe this is not the ideal way to store it, but for the example's sake, let's say that we uh, store the date and amount and use these two to define a loan weakly. So this is a weak representation. These are partial keys, so therefore we are using dashed underlines. What we mean it by this is that to find a unique loan, I need the date and amount, but these are not sufficient. I also need the primary key of the entity that this entity is attached with this weak relation. So with the tick lines, this is the weak entity, loan is the weak entity, and with the tick line, borrows is the weak relationship. We need the primary key of the normal entity, so customer is not weak, right? We need the primary key of the customer, which is CID, and on top of that we need the date and amount from loan to be able to find a unique loan. So the loans cannot exist by themselves, and we can only store them in relation to the customer. With customers, okay, these are our customers, we keep the CID and name, and let's say we give loan to a customer on a specific date with a specific amount. In such setup, we are saying that, okay, on the same date, if this is not storing the hours, for example, there could be only one loan with the same amount. So date could be like, for example, 29th, and the amount is 100, for example, for a specific customer. Then I cannot have in such setup on the same date the same amount of loan. Maybe this is a limitation of this setup. But for the sake of example, we made it like this. But for weak entities, we can convert them into normal entities as well, with additional attributes. Maybe it is better to go in Draw.io with the example. So in our case, let's say users have addresses. So I will duplicate this user entity and write address for it. And let's say for addresses, we do not store the exact address. Let's say we only store the city and the street number. So actually there could be multiple addresses with the same city and street number because we are not storing enough attributes. For example, maybe I need the building number as well to have unique addresses. But in this case, let's say we do not store all the attributes that are required to uniquely define an address. And we are, let's say, relating users with addresses. Let's say I have the relationship lives that relates the address to the user. But there could be multiple users living in the same address, so that's one thing. I would like to make the address a weak entity. I will use the tick line while the shape is selected. For both of the entity and the relationship, I will make the line sticker. And also for weak entities, actually we have a special case for the participation and cardinality constraints. Since we are saying that, okay, this weak entity cannot be identified by itself, we identify it through its relation. Every instance of a loan should participate in this relation. So basically, on the weak entity side, I need total participation always if I'm making a weak entity. So therefore, I will have this. And additionally, I need this one-to-many cardinality as well, because if for one loan there could be multiple customers, then it does not follow our logic. So we are saying that, okay, I identify a loan by the customer it belongs to, but if this loan belongs to multiple customers, then I cannot find a unique instance of a loan. So that's another constraint we should have. So we should have the arrow on the weak side. So I will create an arrow on the address side. Additionally, I need the dashed lines for the partial key attributes. So without partial keys, if I only identify it through the primary key of the customer, then since I'm saying that there could be multiple loans for a customer, again, without the partial key, I cannot find a unique entry. I also need some sort of partial key. It could be one or it could be multiple. In our case, let's make city and street number the partial key. But unfortunately in Draw.io there is no dashed underline, so we should use the dashed line to create it manually. So I will click on the dashed line here. First I will make it 1 point. It should not be tick. And then I will anchor these endpoints to the bottom left and bottom right corners of this ellipse. So if I anchor them correctly, when you move the shape around, the dashed lines will also follow. I create another copy of the dashed line, and on one hand I connect it to the bottom right, and on other end I connect it to the bottom left anchor points, so that these are my partial keys now. And what I'm saying in this picture is, okay, I store addresses that user lives at. So for users, I'm keeping addresses. For each user, there can be multiple addresses. But at each address, there could be only one user. This is what I'm saying in this picture. For a user, there can be multiple addresses, but for each address, there could be only one user. And since I'm not storing enough information for an address, if I have the address, I also need the user's information to find out which address this user, which address, or let me say it like that, which user this address belongs to. Okay. Sometimes people mistakenly think it like this. So if there is no user, there should not be an address. Then it becomes problematic, because you might also think that if there is no users in my system, there should not be any courses. If there are no courses, then there should not be any students. And this is not correct. So don't think the weak relations as this. In some projects, people try to make lots of weak relations, weak entities. So be careful about it. It is better to have no weak entities at all, rather than to make everything weak. So with weak entities, you are basically saying that I cannot find a unique entry for this entity by itself. I need to depend on something else. If you look at this picture, you can identify users, right? With the ID. You can identify individual courses with the course ID. But if you think that if there are no courses, then we are not teaching anything, so I don't need users, then this is incorrect. If you need a weak entity, then that should be based on how you find a unique instance of that entity. In this case, we said that, okay, I cannot find a unique instance of the address because I'm not storing enough attributes for that address. Therefore, I'm also attaching the primary key of the user in this weak relationship to identify a unique address. So in the project descriptions, usually we don't have any weak entities, so don't force it to create some weak entities. Is there any problems, questions? Maybe it's not that clear, but weak entities are kind of rare. and like these are like some examples that we try to make sense. But if you need to make such shapes, you know how to make them at least. Any questions, problems? How do we? I did not understand the beginning. Okay, so this is like lives. So let's say we are storing which address this user lives at. And let's say for each user there can be many addresses. So I have different addresses on different cities, for example. And basically, with the weak relationship, we are saying that if there is an address in our system, that address should belong to a user. So we have total participation on this side, and this is a one-to-many relationship. So this is a special form or kind of relationship. To get rid of the weak part, we can have something like this. We can include an additional attribute, for example, like address ID. For each address, we might keep a separate primary key. In that case, there is no need for the partial keys, and I don't need the tick lines, for example. I also removed the total participation. In such setup, there can be some addresses that do not belong to the users. So weak entities kind of make sure that if I have the address in the system, it should belong to someone. You can also make it happen with total participation, right? With total participation, I'm saying that if there's an address, that address should belong to the user. But then this address ID kind of becomes not that useful. So making the entity a weak entity makes more sense in such setup. Is it clear? Okay, no problem. Any questions, problems? So the weak entity is kind of like sometimes it is kind of hard to understand because it is rare compared to the other kinds of relations. Like for example, even with the addresses and with loans, in real cases, we have some unique identifiers for them. For loans, maybe we have some special numbers that uniquely identifies a loan. For addresses as well, we have some special primary keys to avoid weak entities. So now we are going to look at this example description and follow how we design an ER diagram using the description. Because in your projects as well, we gave you descriptions, and in those descriptions, sometimes some sentences are not directly transferred to the ER diagram. With the ER diagram, what we show is the data that we store and the dependencies between the data. But sometimes we include additional information in the project description about the later stages of your project. Sometimes we might have some implementation details. We might have some limitation for the values of the attributes, etc. So we are going to follow this description to create the corresponding diagram. And let me also show you how we save. It's actually like going through file, and then you have the save option. You can use Ctrl S button to save your diagram, and whenever you open Drawware again, you have the option to like file and open your saved diagram from the cloud options from your device as well. So if you saved it on your device, you just choose the Drawware file to open it again, and we are going to upload the Drawware files for the ER diagrams of the project as well. So let me create a new diagram. Let's say example. And with this diagram, I would like to follow this description. So you are going to design a database for a school, it says. So most of the time, we start with some rough description of what this database is going to be used for. And one mistake you might do here is to include school as an entity. So you should think about whether you need multiple stores, or is it is the database is going to be for just one school only. So in this case, we are designing it for just one school. We do not have like multiple schools that we need to store. So school is not an entity in this case. Users of this system have a unique ID number, name, surname, and password. So in such sentences, we are basically talking about our entities and the attributes of our entities. So in this case, for a user, I need to store the ID number, name, surname, and password. Therefore, I need these attributes and an entity for the user. So I will create such thing, create a new rectangle. This is going to be my user, resize it. And for a user, I need multiple attributes. I will create ellipses for each of them. I need the name. I will duplicate these items. I need the surname. And I also need the password and ID. ID and password. I'm using the hotkey Control D to duplicate my items. And I need simple lines connecting the attributes to the entity. Remember, I was using the center points to connect the lines together. I carry the starting and ending points of my lines to the shapes. So it also saves that I have unsaved changes. If you click here, it will automatically save it to your desktop. That means that since we are using the online version, it downloads a separate copy of the file. So it says that a user could be a student, a teacher, or a staff. Right now, this is not enough to decide on an is a relationship. So this could be talking about the types of users. And with user types, remember, it can be attributes as well. But there is some additional information. It says that for students, system keeps track of amount of scholarship as well. So I know that for a special type of user, for students, I need to store additional data. In this case, I can decide on an is a relationship. So I will include a triangle, and with triangles, remember, we click on the rotation symbol multiple times, 3 times, to make it face up. So this is going to be my is a relationship. I will use the second line of text. I just hit enter at the beginning of the text to use it in the second line. So I know that I need the different types of users, students, teachers, and staff members. These are going to be the children of user. And again, in here, I use simple lines. So we might have arrows only for relations. That's kind of important. Only for normal relations and aggregate relations, right? With is a relation, it's also a relation, but we don't have arrows, or we do not have tick lines. We use the simple lines for this one. Remember, it was saying that for students, there could be scholarship that we store for students. I connect this attribute to the student. For teacher and staff members, there isn't a difference so far. but there could be. We are going to continue with reading the description. It says that a student can enroll to many courses, and a course can have many students enrolled. Sometimes we give the entities first and then define the relations on top, but sometimes in the description it might start with describing the relation first. So far we did not see any description about the course, but it says that an existing entity, a student, can enroll to many courses in our database. And it also says that a course can have many students enrolled. So from here, I can guess that there should be some course entity. And if I continue, it says also we store a grade for each enrolled course. This is about the enroll activity. But further on, it says that each course has a unique course code, course name, and an optional description. So at this point, I know that for sure, course should be an entity, and I have these attributes for a course. Let me go to the Drawio, and before I forget, I should also make ID the primary key, right? Because it was saying that for users, we have unique IDs. I will use Ctrl U on my keyboard to make the underline. So it was saying that students are enrolled to courses. I need a course entity. And for each course, I need to store a bunch of things. And those are course code, course name, and description. So course code, course name, and description. And it was also saying that course code is unique. So these are the attributes of course. Therefore, I need to connect them with simple lines. This is maybe a good point to have this mistake. So if you choose an item, any of the shapes, there are some arrow symbols around. And if you just click on an arrow symbol, it brings another menu to choose an item. I will undo this operation. Or if you click and hold the arrow that appears and like carry the line around, it will create an arrow, which is not very useful for our case. So that's why we include the lines separately and then connect them, because these lines have always arrows, or they are connected to same kind of shapes. For attributes, we do not have such setup. So that's why we are creating the lines separately, but by mistake, if you click on this arrow, you might have an arrow. So just undo in that case. And it is saying that an optional description. The optional part is something for future, right? When we create the tables for our database, we have the option to make an attribute required or not. So it says that basically description is not required to create a new course. For some courses, we might omit the description. But in the ER diagram, we do not show this information. We just include the attribute for that thing. So it was saying that there is a relation between students and courses. It's also talking about the cardinality. A student can enroll to many courses, and a course can have many students enrolled. So from here, I know that it should be a many-to-many relationship. It might say more than one, it might say multiple, but it is talking about the cardinality. And with many-to-many relationships, we use simple lines. So this is an enrolled relation, and I will connect it using simple lines to indicate that this is a many-to-many relationship between students and courses. It was also saying that, okay, this is not the right one, okay. It was also saying that we store a grade between this range for each enrolled course. So I need an attribute grade, but that attribute is not going to belong to a student not to the course, but to the relation. So for relations as well, we can have attributes, right? And this time we are storing the grade that the student gets from that course. And this is included in the relation because if we keep the grade on course side, then there could be multiple students in the same course, but they are going to get different grades. If we keep the grade in the student side, then each student can get multiple courses with different grades. So to be able to get different grades from different courses, we include the grade attribute in the relationship. So therefore, when a student is enrolled to a course, then we can give the grade for that. For the range, again, it's a future task. We can define some limitations for the values of our attributes, and we are not showing this in the ER diagram. And it says that every course must be taught by exactly one teacher. On the other hand, a teacher could teach many courses. So we have the teacher entity, we have the course entity. It is describing a relationship between those. And it is also, again, talking about the cardinality, but this time also about the participation. So every course must be taught by exactly one teacher. So from the one part, I understand that, okay, for a course there can be a teacher, one teacher, there could be one teacher, not many teachers. It is not saying every course can be taught by many teachers. It is saying that every course should be first taught by one teacher, and it also says that exactly one teacher, so it does not allow zero teachers as well. So from the word exactly and kind of from the must, I understand that I need to use total participation, and from this course and one teacher, I understand the one-to-many aspect of it. If you continue, it says that on the other hand, a teacher could teach many courses. So for a teacher, there could be many courses, but for a course, it cannot be. For a course, there could be only one teacher, and it does not allow zero teachers as well. So with this description, let's come to the ER diagram. So we are defining another relationship. Let me have a duplicate of the enrolled. We are saying teaches. So let's start with simple lines first between teacher, and I also need the course on other side. So I will choose these items and carry them around to have a better picture. So it was saying that for a teacher, there could be many courses, but for a course, there can only be one teacher. If you compare it with the owner and dog example, courses are kind of like dogs in this case. So I need the arrow on course side. So I will include the arrow, and it's in the correct part. If it was not, I could have reversed it with Control R or by right-clicking on the line and choosing reverse. And furthermore, we had this total participation constraint. It was saying that every course must be taught by exactly one teacher. So there should not be any course that is not taught by anyone. So for every course, if there is a course, that course should be included in this relationship as well. But this is, remember, different from weak entity, right? For a course, we have actually the primary key. I will underline this course code. Course code was the primary key in the description. We have this course code to uniquely identify a course. So it is something different than the weak entity. Total participation says that all the instances of course should be in this relationship. So we also have the other side of the description. A teacher could teach many courses. So from this arrow, we are already saying that for one teacher, there could be many courses, but for one course, there could be only one teacher. It says every student should have one teacher as their advisor. A teacher may be the advisor of many students. So a similar thing, right? Every student should have one teacher as their advisor. A teacher may be the advisor of many students. So if I create a new relationship like advice between the student and teacher, it was saying that for every student I need an advisor. So here every student should have one teacher as their advisor, not many, just one. And I need the total participation because there should not be any student without an advisor. And furthermore, there can only be one advisor for each student, not multiple. But on the teacher side, a teacher could advise multiple students. Based on how you read the relationship, the name could change. So I can write advice or being advised or advisor. Maybe makes more sense in this case. Teacher is the advisor of the student. And we need to choose one naming for the relation. Of course, we are not saying that student is advising the teacher. It is according to how we read it. A teacher could have many addresses stored in the system, but an address could belong to only one teacher. So far, it is describing some addresses are stored in the system, and each address could belong to only one teacher. Each address has a unique phone number, a city name, and a street number. So let's create an address entity. We are keeping them for teachers. So I have this address entity. I need to store some attributes again, like the phone number, and also city name and street number. Keeping your attribute names short is better because in the future with SQL and when we go into implementation, we need to refer to these attribute names. So keeping them simple helps. So it was saying that phone number is unique, and we have a relation like have between the teacher and addresses. It was also saying that a teacher could have many addresses, but an address could belong to only one teacher. So again, addresses are like dogs. In our picture, this time the arrow was in the wrong side. I will reverse this arrow. This is enough for that description. It also says that if there is an address stored in the system, it should belong to a teacher. From this part, we have the total participation. If we want to make this a weak entity, right now we can with additional assumptions. So we might assume that each address is only partially identified with the phone number. If it was the case, then we can make it into a weak entity. So in the example picture we made it into a weak entity to show the different kinds of elements that we have in the ER diagram. But according to this description only, it is not required to make it a weak entity. But this setup is, with this setup, it is possible to make it a weak entity as well. So if we were to make it a weak entity, we will have tick lines for address and the relationship have, and we will have dashed underlining for the phone number. But let me keep it as it is. Each student can have at most one locker, and each locker could belong to at most one student. So we are assigning lockers to the student. And this is a one-to-one relationship in this case. Each student can have at most one locker, not many, and each locker could belong to at most one student, not many. So let me create a locker. In this case, we don't know the attributes yet for the locker, but we have the relationship. Again, it is kind of like have, or we can give like different names. It helps. Belongs maybe. Or if you want to use the same name, you might assign numbers to the relationships. In the ER diagram, it is okay to use the same name for different entities and relations. But when you go into the database, when you go into the implementation, unique names are required. So it helps to have the unique names. So we have a one-to-one relationship here. So I will have the arrows next to the relationship symbol. A locker is identified by both its floor number and locker number. So it can be identified by its own. It's not weak, but it is identified by both attributes. So this is going to be a composite primary key. I need floor number and locker number. So I will include two attributes, floor number and locker number. You can think of it like we have different floors in the building, and in each floor, let's say lockers start from 1 to some number. So to find a unique locker, I need the locker number as well as the floor number that we store this locker. So I have the attributes of the locker. It says that sometimes a padlock can be given to a student for his or her locker. In this case, the system should keep track of which staff member gives which locker's key to which student on which date. So let's first focus on the first part. So we are giving padlocks to be used for the lockers, to the students for the lockers. So it is kind of similar to classroom example. So with the classroom example, we were saying that, okay, users are teaching courses, but sometimes we assign those teaching activity to classrooms. So in here we have a similar picture. Let me arrange the items so that we have a better view. So carrying items around, this is some good side of the Draw.io. Like if you were drawing this on the paper directly, you don't have the option to easily carry your elements around, then it makes it a harder problem. So between the student and locker, we are assigning lockers to students. And additionally, sometimes we give them keys, not always. So I might have defined it. If we were always giving padlocks, I could have a ternary relationship. But in this case, staff members are giving padlocks sometimes, not always. So I get the sense of an aggregate relation from there. Remember, for aggregate relations, we need the dashed rectangles that surrounds one relationship and the entities that are connected to that relationship. So I should not include enrolled, for example, in here. I'm defining some additional relation on top of the relation belongs. So student has the locker, and for that locker, some staff member is going to give key. So I will create the aggregate relation give key. So this staff member is going to give key to that student for that locker. So if I connect it like this, I know that one staff member is related to one belongs relation. And in one belongs, I have the students and the locker. So basically, I am saying that with a relation, in a relationship, we store the primary keys of the connected entities as foreign keys. We will talk them about later, but I keep the primary key of the student in belongs. So the primary key of the student is inherited from its parent, its ID. So I have the ID of the student. I have the primary key of locker, which is a composite one. I have fno and lno in belongs to relate a student to a locker. And with the give key relation, with this aggregate relation, I store the primary key of stuff, this time the ID coming from stuff, as well as what I have in this relationship, the foreign keys that I store, the primary key of the student and primary key of the locker. Additionally, remember it was also saying that we need to store on which day this staff member is giving the padlock to the student for the locker. So I need an additional attribute that stores the date for this give key relationship. And that is going to be it for this example. And in your projects as well, don't expect too much complicated database diagrams. So there could be like a couple more entities or relations, but it is basically going to be similar. With the aggregate relation, just a reminder, we made sure that whenever we give a key, it is for that student that has the locker. So we are not giving the key to the student directly. Otherwise, we might have some student with key that does not have a locker, because remember, there is no total participation. Some students does not have any locker, and for some lockers, there is no student. Additionally, we are not giving the key for the lockers that do not have a corresponding student. We are only giving the key by this staff member to the students for having that locker. So this aggregate relation made sure that this happens. Any questions, problems? So otherwise, we are done. And remember, we are going to announce your project topics soon. So it will be according to your preferences with first come, first serve. So if you send it earlier, it is most likely that you will get your first option for the project topic. And for the first stage of the project, you are going to design the ER diagram using Drawio for your project. If you do not have... Yeah. Evet. Evet, dinliyorum. Gives key için diyorsun. Şurası. Hı hı. So, so we are keeping the grade for the course that the student is enrolled to. Yani öğrencinin aldığı ders için bir grade tutuyoruz. If that student is, for example, taking multiple courses, then if we store the grade in students, then we can only store one grade, right? To be able to store the grade for each course this student takes, we are keeping it with enrolled. Okay. Any other questions, problems? Okay, then that's it. So for lab 3, we are for lab 2, which is on like week 5, we are going to start using LibreOffice Base. So in earlier semesters, we were using Microsoft Access, but it is no longer offered. I also send you an email, and then there is a guide to install LibreOffice on your systems. So before lab 2, if you install it, it is going to be better. And that's it. So see you. Thanks. Take care.